Hi everyone. Today we're going to do a quick video on correlation coefficients, the idea of making inferences. We've talked about this before. Pearson's R, Pearson's product moment correlation coefficient, the idea of looking at relationship between two variables to see how one affects another. Leading up to this, we went back and looked at the differences between means of populations and samples and seeing how if they're significant or not, right? In the t-test, you're looking at whether one sample has a significant, or the mean of one sample is significantly different than another, or some factor within a sample, or in the ANOVA where you're looking at more than two groups with the F-test as well. But we're moving back to correlation coefficients. This is a a good start into it lays the groundwork for inferential statistics, making inferences about the data, saying that one thing has an effect on another, and this is it's a good starting point because we're going to move towards talking about linear regressions and the idea of linear regression and different statistical methods associated with that. Nevertheless, going back, a correlation coefficient, a correlation itself means that there's a relationship. That's really what it means. These are just some little facts we're going to talk about. Correlation does not mean causation. This is one thing that everybody needs to pay attention to. Just because two variables correlate with one another, it doesn't mean one causes the other or one has an effect on the other, right? The old example used is ice cream having an effect on crime rates, because once ice cream sales go up, so does crime. But there's other factors that need to be accounted for, right? And this is when logic and theory come into play. So theory should drive research. What causes ice cream sales to increase? Well, it's probably hotter outside. It's summertime, right? As opposed to in crime. What makes crime increase? Why is crime increase in the summertime? Well, it's warmer, the sun's out longer, people are out, kids are out of school, and all these other factors are involved, and they more or less have an effect, right? When it's 20 degrees outside, or there's 3 feet of snow, people aren't necessarily out there. I mean, some people are, but the levels are much less, committing crime. So that has an effect. Weather has an effect, and seasons have an effect. All right. So when you're looking at correlations, you can't just go and willy-nilly look at things and try and make assessments and say that one has a significant effect on the other, unless you're not relying on theory to drive that, or logic and reason. All right. Here's a couple other descriptions of correlations themselves. Correlation coefficients. The magnitude can be used to examine the strength of a relationship, so you can see how much of the variation in one variable is caused by another. The ranges themselves is from -1 to +1. Direct relationships and indirect relationships. We talked about these things previously, so I'm not going to go into too much detail. But here's our chart again, right? We've completed t-test for dependent samples, t-test for independent samples, and ANOVA. We didn't really talk about this one here, repeated measures of analysis of variance, but that's okay as well. But regardless of that, this is looking at the differences between groups, all right? The differences between groups, the averages between groups, if they're significant. This is looking at the relationship between variables, all right? How one variable relates to another. If one increases, does the other increase, or does the other decrease? That's a relationship. Instead of comparing, this is the average of this group's marijuana use versus this is the average of this group's marijuana use, right? We're looking at what causes marijuana use in the first place. This is where inferential statistics comes into play. How many variables are we dealing with? Just 2. This is correlation coefficients, and we're going to move to here more than 2 variables, regression and factor analysis, and all these other statistical techniques that we're going to briefly touch on. So let's keep that in mind. Now the Pearson's R, here's the formula for it. It can be computed by hand. If we have more time, I'd definitely go through the steps to go through it. But nevertheless, the null hypothesis, the population that there is no x and y, x being an independent variable, y being the dependent variable, cause, effect. X does not have an effect on y. All right. The alternative hypothesis or the research hypothesis would be that there is a significant difference. There is a significant effect that is observed there. So interpreting your results, this is kind of what an interpretation kind of looks like and how you would type it up. The R value, degrees of freedom. R is the test statistic. 8 is the degrees of freedom. This would be the achieved value and the probability. All right, this is how you would type it up. And we're just going to work through a quick example. We've done this before, so I'm just going to quickly go through this real quick. You can do, we're just looking at a quick example, days spent in a rehab facility, a rehabilitation facility. And this would be our independent variable, saying that has an effect on the days someone uses marijuana 1 year after rehab, after spending time in rehab. All right. So the assumption here, this is logically consistent and is grounded in theory that the idea that rehabilitation has an effect on drug use, right? So we can just use the correlation function, and we'll do array 1 here, comma, and array 2. See how it has it all typed up there? And this is our value, okay? This is the achieved value. Now that's our correlation coefficient, and we could square this value. And if you square the value, I think it's about 0.64, and we would say 64% of the variation in days using marijuana after rehab, 1 year after rehab, is associated with the days spent in rehabilitation facility. Another way to compute this, we can use the data analysis tool, use the correlation tool. All right, we'll do our input range here. We'll just do this, highlight this all, put the labels on top, and we'll put our output right here. Okay, so this is like a correlation matrix. If we had more than one variable, it would list them all out, and you would get relationships between all variables. All right, but this is days spent in rehabilitation facility, and that's a perfect correlation. See, that's 1. It's 100%, and it perfectly correlates with itself, and that should make sense. Days spent, days used marijuana after rehab, days used marijuana after rehab. See, that's a 1 itself too. That's a perfect, that's 100% correlation. Here we see that there's a negative effect here, or there's a negative relationship that's observed, okay? And what does that mean? How do we interpret this result? This is the meat and bones of this, this little quick video actually, is interpreting this result, all right? So you can go, there's tables online that tell you what that R value means and how to interpret the result. So degrees of freedom, how we have 8. So there was 10 subjects in the sample, and I said that n-1, right? If you always think of n-1, there's 2 variables. So n-1, n-1. So out of 10, minus 2. That's how you get your degrees of freedom for the correlation coefficient, okay? So that should make sense itself. Now, when you go to the table, there's one in your textbook. We'll look at the degrees of freedom here. We know that it's 8. And this is a one-tailed test because we're looking at a direction, right? Marijuana, time in rehab should decrease marijuana use, right? So this is the obtained value of negative 0.08, negative 0.809, I'm sorry. And that should exceed the critical value here. And indeed it does. It exceeds 0.5494. The 0.05 level, and in fact it exceeds the 0.01 threshold, which would be 0.7155. All right, anything that falls below it does not exceed it. Anything that falls above it does exceed it, and therefore it's significant. So how do you interpret it? This is how you would interpret it, okay? And it's important you pay attention to these interpretations. It's not good to go around and deviate much from this model. And I'll get to that in a second, but here's how you would interpret it. The Pearson's product moment correlation coefficient value of negative 0.809 exceeds the critical value of 0.549. This is it. That's the formula I showed you earlier. You should write that. You should write that in your results when you're interpreting. Okay. How do we know it's P is less than 0.05? The probability of it occurring is less than 0.05 because it exceeds that value. As a result, null hypothesis can be rejected. and one can conclude that the total number of days spent in a rehabilitation facility significantly decreases the number of days individuals use marijuana in the year following treatment in this sample. All right. This is a perfect model. I wanted a way to explain this finding, right? And you shouldn't deviate from it, all right? Don't say, I accept the alternative hypothesis, or, I fail, whatever, all right? Just, it's either, null hypothesis can be rejected, or you fail to reject the null hypothesis. And I know it seems really dry and consistent and straightforward, and it should be. It's the statistics. It's not based on opinions. It's not saying that, well, I think treatment works, or I think that treatment doesn't work. Well, the results here suggest that this treatment program does. All right. Do we know that it works all the time? No. That's why the assumption that treatment doesn't have an effect on marijuana use, right? There's a lot of factors that should probably be accounted for when you're assessing this type of thing. Perhaps, the age of the individuals, their previous drug use habits, the number of times they've been incarcerated, all these other factors that come into play. Do they have mental health issues? So just looking at that alone might be problematic, and it does open the door for other questions. But the interpretation itself is sound, and that can't necessarily be challenged, all right? Not from somebody, because it's not opinionated. This is based on numbers. This is based on facts. And the way it's stated leaves little room for error. It leaves little room for argument. Statistics, in the social sciences, we borrow statistics, and we use imperfect measures on fairly perfect assessments, let's put it that way, right? These things can be proved, all right? All the statistical methods, statistics is a completely different branch of sciences, obviously, and all these methods can be proved. The way we measure things in the social sciences, there's all sorts of error that's involved that underlies it. Nevertheless, this interpretation leaves nothing open, all right? And it's simple to the point, and it's direct, and that's how you should be when you're working with data. And as a scholar and as somebody with a degree, instead of working with somebody's opinion, well, Bob Joe went to rehab and he was using drugs the next day. Well, that's fine, but is it consistent with, things in the aggregate, the population or this sample or this rehabilitation facility or whatever, right? Another extension onto that interpretation, which is very concise, very specific, you can also square the value to estimate how much of the variation is shared. So we had negative 0.809. You can square that value. So you multiply it by itself, and this tells you, essentially, once you square a correlation coefficient, you can get the percentage of shared variance, okay? 65.4% of the variability in marijuana use is determined by the number of days spent in rehab, all right? So essentially 65% of the variation that is associated with marijuana use is explained by the number of times somebody spent in a rehabilitation facility. And 34.6% is unaccounted for. This minus 100 is 34.6%. Hopefully that makes sense. That would be really the only logical extension that you can add on to this interpretation of your results here, okay? Hopefully all that stuff makes sense. Now, on a final note, I want y'all to just reiterate the point that correlation doesn't mean causation. Just because two variables are significantly correlated or insignificantly correlated with one another doesn't mean one causes the other, or vice versa, right? That's why theory should drive research. It's important to base your stuff on things that are already known. Somebody's done research on it in some capacity. Anything you're trying to think of, any type of relationship within the social sciences for the most part, or something that gets really close. And that stuff should be based in theory. Otherwise, you're going to get people believing that ice cream sales increase crime out there. So understand what you're doing. Things should be logical, and they should be consistent, and they should be practical, right? So hopefully this video helps, and hopefully it gets you guys going. Y'all take care, all right?